Hi, I'm Patrick Reagan. Welcome to the Advanced Networking Concepts, Part 7, Networking Virtualization Part 2. This video continues our discussion on technology used in modern environments that include network virtualization. In Part 2, we will discuss VXLAN, SASE, SSE, and IAC. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Virtual Extensible Local Area Networks, or VXLAN, is a networking virtualization technology that allows multiple logical networks to be created on a single physical network by encapsulating Layer 2 Ethernet frames within UDP packets, essentially creating isolated virtual networks on top of a shared physical infrastructure, often used in large data centers and cloud environments to overcome the limitations of the traditional VLANs with a much larger address space. The VXLAN Tunnel Endpoint, or VTEP, is a device responsible for encapsulating and decapsulating VXLAN packets, acting as an entry and exit points for the virtual network. Data Center Interconnect, or DCI, refers to the use of VXLAN technology to connect multiple data centers together, allowing for seamless Layer 2 network connectivity across geographically separate locations by essentially creating a virtual overlay network over the underlying Layer 3 IP network. VXLAN enables efficient traffic flow between different data centers through VXLAN encapsulation and decapsulation managed by VXLAN tunnel endpoints located on each data center's edge devices. In essence, VTEP encapsulates Layer 2 frames with UDP packets. This process forms the VXLAN tunnels. VTEP uses VXLAN network identifiers, or VNIs, to differentiate between the different VXLAN segments. This allows for the isolation of traffic and prevents communication between segments unless explicitly allowed. VTEPs are responsible for forwarding encapsulated traffic to the correct destination VTEP based on the VNI. Key points about VXLAN include function. It enables the creation of isolated virtual networks by encapsulating Layer 2 frames into Layer 3 packets, allowing traffic to be routed across a physical network based on unique identifiers called VXLAN network identifiers, or VNIs. Scalability. VXLAN overcomes the limitations of VLANs by offering a much larger address space, enabling the creation of significant higher numbers of virtual networks. Use cases: large data centers with many virtual machines, cloud computing environments where multiple tenants need network isolation, and service provider networks requiring flexible network segmentation. This figure shows a VXLAN overlaid network where the VTEPs on each side encapsulates the local Layer 2 LAN segments into the VXLAN tunnel that rides over the IP underlaid network, effectively extending an L2 segment across an L3 fabric. VXLANs are used to accomplish network segmentation beyond what classic VLANs can deliver. Classic VLANs offer only 4,094 virtual networks, while VXLANs offers up to 16 million. VXLAN is primarily used with large data centers, service providers, networks, and cloud operator networks where 4,094 virtual network limit of classic VLANs is too constraining. As the VXLAN becomes supported by more, less expensive switch processors, it's beginning to move out of the data center and into campus networks. Secure Access Service Edge, or SASE, is a cybersecurity and networking framework that combines wide area network capabilities with cloud-delivered security functions into a single service model. SASE aims to provide secure, scalable, and efficient access to applications, data, and services regardless of user location. It can be divided into WAN Edge, or Network Access Edge, which deals with managing network traffic and connectivity, typically implemented using SD-WAN technology within a SASE framework. It includes the physical or virtual demarcation point between the organization's internal network and the public internet, often managed by a WAN Edge router. And Secure Access Service, which is the collection of security functions delivered as a cloud service at the WAN Edge, providing real-time threat protection and access control for users and devices trying to connect to the network. Core components of SASE include networking features include software-defined WAN or SD-WAN, which optimizes connectivity across the WAN for better performance and reduced latency. Cloud-based architecture, which moves traditional networking and security functionalities to the cloud while providing cloud optimization to ensure low latency, secure, and reliable access to cloud applications. It also provides traffic prioritization and quality of service, or QoS, and support for remote users. Security functions are cloud delivered, which include Secure Web Gateway, or SWG, which protects users from accessing malicious or inappropriate websites. Cloud Access Security Broker, or CSB, which provides visibility and control over cloud-based applications and services. Firewall-as-a-Service, which delivers firewall capabilities directly from the cloud. And Zero Trust Network Access, or ZTNA, which enforces granular entity-based access control for resources. This figure illustrates a SASE architecture where users connect from home, branch offices, and mobile connections, sends traffic to a cloud-based secure service edge, plus SD-WAN, WAN edge, which then provides secure, optimized access to destinations like headquarters or data centers, SaaS apps, and public cloud. How they work together in SASE. SASE integrates security and networking functions into a single service that connects users securely to applications or resources, whether they're hosted on-premises, in the cloud, or at remote locations. SASE provides centralized management by combining the network connectivity functions of a WAN with the security capabilities of Secure Access Service, allowing for unified policy management from a single platform. Instead of deploying separate security appliances on premises, SASE delivers security services from the cloud, which can be scaled and updated easily. This framework eliminates the need for backhauling traffic through a central data center, enabling direct-to-cloud access while ensuring robust security. Benefits include enhanced security, combines multiple security services to protect data, devices, and applications. It implements zero trust principles, ensuring users have access only to resources they need. Improved performance. SD-WAN optimizes routing for better application performance and minimizes latency by allowing secure, direct access to cloud resources. Simplified management. Consolidates networking and security tools into a unified solution and reduces complexity for IT teams. And scalability. Adapts to the growing needs of remote work and cloud services, and easily scales to accommodate additional users, applications, or locations. It also enhances user experience for remote workers and optimizes costs by eliminating the need for multiple point solutions. While SASE offers numerous benefits, implementing it can require re-architecting existing networks and security frameworks, and partnering with reliable service providers to ensure high availability and performance. SASE is considered a transformative approach for organizations seeking to adapt to the demands of the cloud-first strategies and distributed workforces while maintaining strong security postures. Security Service Edge, or SSE, is a framework that integrates multiple security services like secure web gateways, cloud access security brokers, and zero trust network access. It is a component of SASE. It aims to secure user access to the internet, cloud services, and private applications regardless of user location. While SASE is the combination of networking and security services for your environment, SSE is the security part of SASE, focusing on security tools as opposed to the networking capabilities. Besides including the secure web gateway, cloud access security broker, zero trust network access, it also focuses on data loss prevention, or DLP, and threat protection and malware prevention. Leading vendors and products that offer SSE include Zscaler, Palo Alto Networks, Cisco Umbrella, Netscope, and ForcePoint. Infrastructure as a Code, or IAC, is a method of managing and provisioning computer infrastructures, such as servers, networks, storage, and other resources, using machine-readable configuration files instead of a manual physical hardware configuration. IAC allows for automation, consistency, and reproducibility of infrastructure deployments, making it a foundational practice in DevOps and modern software engineering. It essentially defines the desired state of your infrastructure through text files or code instead of manually configuring it through our graphical interfaces, allowing for automation and consistent deployments across different environments, significantly reducing errors and improving efficiency. Definition code, which is infrastructure, is defined using code and a descriptive language such as YAML, JSON, or HCL. Version control, which is the code is stored in a version control system such as Git or GitHub, enabling tracking, rollback, and collaboration. Execution by tools. Tools such as Terraform, Ansible, and AWS CloudFormation process the code to create, modify, or destroy resources in the target environment. Idempotency, which ensures that applying the same configuration code multiple times produces the same results, avoiding unintended side effects. Benefits include faster deployment, which quickly provisions new environments for development, testing, and production. Consistency, which ensures consistent infrastructure across different environments by applying the same code. Scalability, which easily scales the infrastructure up or down based on demand by adjusting the code. And reduced errors, which minimizes manual configuration errors by using code to define infrastructure. IAC uses Playbooks, which act as the primary automation scripts written in a declarative format, defining the desired state of infrastructure by outlining a series of tasks. Templates, which allow for dynamic configuration based on variables, and reusable task-enabled modularity by creating smaller, independent units of automation that can be incorporated into various playbooks across different environments. And reusable tasks, which break down common tasks into smaller, independent modules that can be included in the multiple playbooks, which avoid repeating code by creating reusable tasks for frequently performed operations like user creation, package installation, and service management. Infrastructure as a code helps manage configuration drift by defining the desired state of infrastructure within code, allowing tools to automatically detect and correct any deviations from that defined state, essentially ensuring consistency across deployments. This significantly reduces the risk of manual errors that can lead to configuration drift. By storing infrastructure configurations in central code repositories like Git or GitHub, IAC allows for version tracking, enabling easy rollback to previous configurations if drift occurs. Most AIC tools can integrate with cloud APIs to dynamically retrieve information about your virtual machines, containers, or other resources. To achieve dynamic inventory using inventory scripts, IAC tools often use custom scripts that query external sources and generate the inventory data on demand. In IAC, source control is used to track changes made to the configuration files that define infrastructure, allowing for identification of conflicts when multiple people modify the same code. It enables use of branching to isolate changes and manage different environments by creating separate development paths within the code repository, which ensured a streamlined and controlled way to manage infrastructure updates across various stages like development, staging, and production. With source control, team members can easily review each other's changes before merging them into the main code base, improving code quality and consistency. When a developer makes modifications to an infrastructure configuration file, they commit those changes to the source control system, effectively creating a snapshot of the current state of the code. To integrate changes with the main code base, the developer typically initiates a pull request, allowing other team members to review the proposed changes before merging them. If multiple developers modify the same part of the configuration file simultaneously, the source control system will identify the conflicting errors when attempting to merge changes requiring manual resolution. The version history allows for easy tracking of changes and the ability to revert to previous configurations if necessary. Teams can work together on infrastructure changes, leveraging code reviews and merging features seamlessly. Common source control systems used for IAC include Git, GitHub, and GitLab. Examples of IAC tools include Terraform, which is a popular open source tool for managing infrastructure across multiple cloud providers, AWS CloudFormation, which is a cloud-specific IAC service provided by Amazon Web Services, Azure Resource Manager, which is Microsoft Azure's IAC tool, Chef, which is a configuration management tool that can be used for IAC, and Puppet, which is another widely used configuration management tool for IAC. Question: what is the characteristic of VXLAN? Answer: it is a multi-tenant solution. Question: in a VXLAN-based network, which of the following best describes the main function of a VXLAN tunnel endpoint, or VTIP? Answer: a device that performs VXLAN encapsulation and decapsulation. Question: which component of the Secure Access Service Edge, or SASE, solution provides complete session protection regardless of whether a user is on or off the corporate network? Answer: zero trust. Question: the company is in the process of migrating to cloud-based services. The company's IT department has limited resources for migration and ongoing support. Which of the following best meets the company's needs? Answer: SASE. Question: what provides security for SASE? Answer: SSE. Question: a company reduced the area utilized in its data center by creating virtual networking through automation and by creating provisioning routes and rules through scripting. Which of the following does this example describe? Answer: IAC. Question: which of the following should a systems administrator use to ensure an easy deployment of resources within the cloud provider? Answer: infrastructure as code. For more information, visit these sites. In summary, Virtual Extensible Local Area Network, or VXLAN, is a network virtualization technology that allows multiple logical networks to be created on a single physical network by encapsulating Layer 2 Ethernet frames within UDP packets, essentially creating isolated virtual networks on top of a shared physical infrastructure. Secure Access Service Edge, or SASE, is a cloud-based architecture that combines network connectivity functions with various security services, delivering them through a single platform to securely connect users and devices to applications across different locations essentially merging network and security into one unified service. Security Service Edge, or SSE, is a framework that integrates multiple security services like secure web gateways, Cloud Act security brokers, and zero trust network access. It is a component of SASE. Infrastructure as Code, or IAC, refers to the practice of managing and provisioning IT infrastructure using code, essentially defining the desired state of your infrastructure through text files or code, instead of manually configuring it through our graphical interfaces, allowing for automation and consistent deployment across different environments, significantly reducing errors and improving efficiency. Thank you for watching this video. The next video will be Advanced Networking Concepts, Part 8, Zero Trust. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.